Okay, part 2 then says to find the inverse function for f of x. So to do that, this is the way I always do it. There's slightly different ways you can do it. I set f of x to be y just because it's easier to work with a y than f of x. And then I'm going to rearrange this to make x the subject. I'm going to take away 2. And then just like we did in the other question, if this is true, then e to the power of this, e to the y minus 2, is going to be equal to x plus 3. And therefore x is going to be equal to e to the y minus 2, take away 3. So that's now got x as the subject. So its inverse function is then going to be f dash of x, and then we just swap this y for an x. So that's the inverse function. The other part of the question wanted us to state the domain of the inverse function. So that's asking what values of x can we put in. If we draw a little picture, this is going to be, well, the normal e to the x graph looks like this, going through 1 there. So our graph is going to move up. Well, we don't even need to think of that. What we can do is say, well, normally x needs to be, the output needs to be greater than or equal to 0. We were told in here that the output is greater than or equal to 0. So e to the x take 2, take 3, needs to stay greater than or equal to 0. So again, if we make x a subject, that will tell us the domain. So I'm going to add the 3 back on. I'm going to take logs so that we can say that x minus 2 is greater than or equal to the natural log of 3. And so the domain is that x is greater than or equal to 2 plus the natural log of 3.